Guys, you're welcome back to chemistry studies. So what we'll be looking at today is electrophiles and nucleophiles. So what are nucleophiles and what are electrophiles? Nucleophiles are those chemical species that donate pair of electron to another chemical species called electrophiles to form a chemical bond in a chemical reaction. Also, electrophiles are said to be Lewis acid, while nucleophiles are said to be Lewis base. So from our dictionary meaning, what is the meaning of phile? When you say phile, it means that you have attraction or likeness for something. So for electrophiles have attraction for electrons, negative charges, while nucleophiles have attraction for positive charges. To understand, let's take this as our nucleophile and this as our electrophile. So these are electrophiles here now. As from our definition, nucleophiles are electron donors. So our nucleophile here has 8 electrons, or maybe let's say have 8 mangoes for better understanding. This our nucleophile here has 8 mangoes, and this our nucleophile here, electrophile here, doesn't have any. So what is this nucleophile here gonna do? This nucleophile here is gonna give out maybe 2 or 3 pairs of its electron to this electrophile here. So I hope this helps. So like this our nucleophile here is sharing its electron with this electrophile here. So let's have a look at examples of electrophiles and examples of nucleophiles. Examples of electrophiles are boron fluoride, aluminum chloride, then our hydrogen ion. Examples of nucleophiles are, we have our ammonia, we have water, then we have our hydroxide ion. So these examples of nucleophiles. So let's look into our structures. So our electrophiles are normally positively charged and our nucleophiles are normally negatively charged. We'll look into their structure. Look at their structures now. Let's look at the structure of boron fluoride. Like we said earlier, electrophiles are those ones that need electrons. They need electrons. So look at their structure. They don't have lone pairs of electrons. So boron fluoride. Let's look at its structure to see if it has a lone pair of electrons or not. So boron is the central atom attached to the fluoride. So as you can see, it doesn't have a lone pair of electron. So let's have a look at aluminum chloride. This is the structure. Have 3 chlorides attached to it. So as you can see, they don't have lone pairs of electrons and they need electrons. That's why they are called electrophiles. So let's have a look at examples of nucleophiles. Look at ammonia. Ammonia is NH3. So let's have a look at its structure. Nitrogen is the central atom, then attached to 3 more other hydrogen. As you can see, it's still remaining 2 other electrons. So this balance now. As you can see, nucleophiles have at least 1 pair of lone electrons here. So let's have a look at another structure. Let's have a look at water. So oxygen is the central atom attached to other hydrogen. So it's still not yet balanced. So we see this one has 2 lone pairs of electrons. So that's why they are called electrophile. They have excess electrons to borrow out to those electrophiles. So that's why they are called nucleophiles. Hope you understand. Have a look at ionic reaction between hydroxide ion and hydrogen ion to form water. Okay. So Okay, these are example of nucleoelectrolytic reaction to form water. Okay. Okay, so here our oxygen has 1, 2, 3, 4, have 3 lone pairs of electron. So it's gonna give out 2 lone pair. It's gonna share 2 lone pairs with this hydrogen ion here to form water. So here they have only, in the product have only 2 remaining. So you can see this hydroxide ion here share 2 of its electron with this hydrogen ion here to remain 2 here. So you can see how electrophiles and nucleophiles work. So thank you guys, and please don't forget to subscribe to this channel. I have a lot to offer. I'm still doing my best. Don't bother about the video quality. If God should provide, I pray that I'll have a better camera and everything is gonna be fine. Thank you guys.